So our notes, that's what we just did. The study set was all of our doing all the math. So tonight we're going to talk about equations. And the key with tonight is how I ended. We're doing states of matter. So most of you are writing the equations, which is great, hopefully. And yeah, work on the math of showing your work. All right. So we're going to do what are called net ionic equations. And that last problem on your study set, that's what it was showing. And so there are 3 steps that are involved. And the first step is we write our balanced equation. I just label it as B down here. So we're going to walk through this first one as I add pieces up here. So the question says solutions of copper 2 bromide and silver chlorate. All right. So copper 2, let's do it in blue for copper. That 2 is the copper's charge. So again, write the charge up above. A reminder, Ide means there is no oxygen, just bromine as a -1. So we need 2 bromides. So if the charge is not the same, you need a subscript. Subscripts are coming from the charges. And means plus. Silver, just talked about silver. It's on your study set once or twice. It's on the worksheet. I didn't give you a number here for silver. What number does silver like?
+1.
Yeah, like +1. It is. Now it's stuck with you. You'll be. And this is chlorate. So this is a polyatomic. So yeah, getting everything organized. If you don't know your polyatomics, right? Your list of polyatomics, chlorate, it's one of the ones that was on that lab. Just have a nice list. So you can do things efficiently rather than having to Google every time you're looking. Have a nice list that I keep giving you. You guys get so much. And so having appreciation for realizing that. All right, it's a double. If you like, you can put a parentheses around the chlorate. I won't mark you wrong. This is where they're going to swap. Now, you can put the states in now, or you can do it at the end. Let's go ahead and swap. So I start with my copper. It keeps its charge, and it goes with the chlorate. I know it's a double because they each have a partner. And so this is the swingers. They just switch partners. The copper is going to go with the chlorate. They keep however they were with their charge. So we need 2 chlorates here because the copper has a 2 charge, and the silver goes with the bromide. Just 1 silver and 1 bromide. So don't bring the subscripts over. Bring the charges over, and the charges determine the subscripts. The exception about subscripts is the polyatomic chlorate is ClO3, so that 3 you do bring over. All right. The most missed thing right now ends up being balancing, because we're learning a new piece, which is adding the states of matter and then doing the tie-nye. So remember to balance your coefficients. You'll remember in the next step because something won't work out right. So you have the 2 bromides. So over here, I need 2 in front of my silver bromide. It gives me 2 silvers, which is great. And that gives me 2 chlorates, and it's good. So always metal before non-metal. So always the positive before the negative. States of matter. The reactants will be given to you. Solutions means aqueous. So these are both aqueous. So the products. That's back to what we talked about. There is the chart at the end of your notes that Major was referring to. So you would look up your products. So chlorate, Well, chlorate's up here is one of the ones that is very soluble. So chlorate gets to be aqueous. Silver bromide. So bromide, it says it's soluble unless it's with silver. So up here, these are the ones that are aqueous, and the exceptions, again, the heavy metals, silver, mercury, and lead, they precipitate with lots of stuff, chlorides, bromides, and iodides. So this is our solid. So that's the idea of the chart. That's your study set. Has a couple of these to walk through. So a reminder again, silver, mercury, and lead, they are heavy metals. The 2As, the second column, are called the earth metals because they form solid precipitates. So precipitates, this reaction is a precipitation. Let's label that. You're no longer going to just call it a double. You can call it a DD precipitate. That's what a lot of students do, because the DD helps them to know they swap, and then they say, okay, I got a solid. So that's our first step. Any questions? The good news on this page is we're not going to do any Leo Gurr because they're doubles. All right, number 2. Step 2 is called the total ionic equation. And this is where in the syllabus it said we were doing this lab, and my heart wasn't into it, so I've changed things around. Underneath this table on that last page of your notes, it does walk through an example and has the words and stuff, so just know it's there. And then there's a story, my first little story, if you like the short stories. So what the total ionic is, the trick with that, in just a few words, anything that is aqueous, it is that aqueous means that it is actually not a compound. That means it's dissolved. And so you write it as ions. So you show the ions. So you separate as ions. That's it. That's what we're going to do. So with that, though, you don't separate everything. Solid, liquid, and gas. These states of matter, they are still compounds. So they stay as compounds. It just takes a little bit of practice. So we've been adding steps. So we got used to doing the math, and we added the titration step, and you can do it. So we got into writing equations, switching. We started adding states of matter, and now we're going to do the total ionic. And then there's one more step. So the Ni is something different. So aqueous, it means we write copper as an ion. As an ion means you show the charge. Now, just because I did not give myself enough space, there is a small shortcut that I'm okay with. And I think I'm just looking to see if I mentioned it here. So typically when you write each of these ions, you're supposed to write aqueous after every single ion. But you have to show the charge. If you are writing it as an ion in the total and then in the net, you can leave the aqueous off. I'm okay with you just writing, okay, now I have copper ion. Now, the thing you have to be careful with is the subscripts move to coefficients. So what you have is a copper ion and 2 bromide ions. So coefficients move and become, subscripts move and become coefficients. And then this coefficient, it's a distribution thing. This coefficient refers to both the silver and the chlorate. So we have plus 2 silver ions and 2 chlorate ions. Yeah. Questions? Why does this 3 stay there? I just said subscripts move, and then I left that subscript there.
It's a polyatomic.
It's a polyatomic, yes. So polyatomics, they keep their subscripts how they were. All right, we show our arrow. Over here, we're going to still have a copper ion. So copper with a 2 charge, and this 2 becomes a coefficient. So 2 ClO3. The 3 is part of the polyatomic, but the 2 is how many I had. So ClO3 with a negative. And again, you should technically write aqueous, 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 aqueous. In the B, you always show all your states of matter. In the tie, I'm okay if you don't write aqueous, aqueous, aqueous 6 times. You do not break the next one apart because it's a solid. It is a compound. It's the precipitate. That is what happened. The silver and the bromide came together, formed a solid precipitate. We would have seen a white, cloudy, milky color show up probably. All right, let's do the next one. So step 3. Bright green. So step 3 is the net ionic. We gotta do a brighter color. Let's see if the I can't find my red.
So the reason why we didn't break the 2 AgBr is just because it's a whole solid. It's not aqueous.
It's a solid liquid gas. You don't break apart.
Okay.
Exactly. Only aqueous. So only aqueous do you break apart. So the net ionic is just one more step. You cross out spectator ions. That's it. So the total ionic shows all the ions. It shows everything that's there. So what does it mean to be aqueous? I often ask this question on the midterm, not worded quite like that, but what does aqueous mean?
It can be dissolved in water.
It's dissolved in water. It means it's just floating around aimlessly in the water. The word ion actually comes from Io, who, right? She's just roaming. She's all of us roaming around aimlessly on this planet. So the spectators, anybody want to guess what the spectators are in this question?
The coefficients?
The spectators are the ones that are ions on both sides. So ions as a reactant and ions on the product side. So we'll just say ions on both sides. So you can cross them out. You can underline them. You don't bring them with you to the net. So that's where a different color. So copper ion crosses out. And the chlorate is going to cross out. And then we just bring down what we're left with, which is 2 bromides. Still show it as an ion. If you want, you can write aqueous. I'll write it this time. I don't like writing it. I have 2 silver ions. Oh, I can't believe I did this. By the way, the states of matter are written after as a subscript. You can also write them down below, except things start getting crowded. You do not write it before. Never, ever write it before, and you don't write it above. It will get marked off. So it should be written after. And we end up with 2 silver bromide solids. So again, on the total, you can leave off all the aqueous. You do want to show the solid because that's what happened. So what the net shows is what happened. You had silver and bromide ions, and when they came near each other, they actually have this affinity and they form a precipitate. The copper and the chlorates, they're just still, they're there. It's not that they're not there. They're just aimlessly moving around still. They have no interest in anything. I do want to mention, there's one more step on this one. This happens only occasionally. Does anybody see what the last step might be?
Oh, cross out all the 2s and make it.
Thank you, Spencer. Yeah. all these twos. This does not happen very often, but if you end up with twos everywhere, you do reduce them. Again, yeah. All right, is there any questions? What I'm going to do is I'm going to pause for like 5 minutes. You can take a break or for 7 minutes, or you can try 1, 2, or 3 of these. So unless there's a question, I'm going to pause this. All right, so we're back. Potassium carbonate, so K2CO3, and nitric gas is HNO3. The subscript 2 is to balance the charge. So again, if they don't have the same charge, you'll have a subscript. Here they have the same charge. You can put parentheses if it helps you around your polyatomics, but you don't have to. And so the K ends up with the NO3. They each have a 1 charge, so we just want 1 of each. Don't bring this 2 over. The 2 will end up in the front, but we'll get there in a minute. And then the hydrogen goes with the carbonate. So we're going to need 2 hydrogens because the carbonate has a -2 charge. So balancing for that 2 would be 2 HNO3s and 2 KNO3s. Double displacements are wonderful, easy to balance if you respected the charge and you just switch partners. So keep that in mind. All right, states of matter. So we have aqueous for our first 2. You see Nick the camel always swims, so nitrates are going to be aqueous. And then this is a special one, H2CO3. So acids are almost always soluble. This is our exception. So does anybody remember what this one does? You'll all know by next week if you don't know.
It breaks
now.
apart into CO2 and water.
Yeah, this is the gas forming one. So it's going to form H2O, which is liquid, and CO2, which is a gas. Now, this is actually how you're going to see me doing it when I do these from now on. I actually will initially write it as the compound, and then in my next step, I show it broken apart. What I find is about half the students, because it makes it easier to balance to show it as the compound. About half the students will do it this way, and about half of you will just never write the H2CO3, or you can cross it out and above it write the H2O and CO2. It doesn't matter to me as long as the step. As H2CO3, technically is aqueous, but if you write it as aqueous, then you're not going to split it correctly. So this is a gas forming. So it's a double displacement gas forming. And we talked about this right at the end of the class on Tuesday. All right, so aqueous, we end up with 2 potassiums and a carbonate. And then this 2 goes to both ions. So 2 hydrogen ions, you must show the charges now, and 2 NO3s. Remember, we work with binary. So each compound breaks into 2 ions. You might have a coefficient with them, but there's always just 2 types of ions. And then we do our arrow, and this, we get 2 potassiums, 2 nitrates. Now, if you forgot to balance your equation, you're going to know, because when you cross out your spectators, they have to be the same number on both sides. And if they're not, something went wrong there. So my spectators are the potassium and the nitrate, so 2 of each. And we bring down for our net equation is the carbonate ion plus the 2 hydrogen ions. And we get H2O as a liquid and CO2 as a gas. So questions with that. So in the balanced equation, the first one, everything has to have states of matter. In the tie and the ni, if you leave off your aqueous, I'm okay with that, especially in the tie, because it gets, if you like to hear, that can help to show these are ions. You have to show the charges. That's probably the most missed thing on this is students get lazy. So don't show your charges with your ions once they are ions. So that's what the I and the ti and the ni mean. All right, next equation is phosphoric acid and sodium hydroxide. So underline your pieces. Phosphoric acid means hydrogen with phosphate, so H3PO4. And sodium hydroxide is NaOH. Now, you don't have to show charges. I don't need them. You would hope your teacher could do this whole thing without it. I recommend, though, you write them up there because it does help for most students to swap them correctly. Again, writing them up above or writing them in a different color. All right, when they switch, the hydrogen is going to go with the hydroxide. So write it just as an H and an OH. That is H2O, which is a liquid. So you can write it either way, HOH or H2O. Don't write as H3OH. That doesn't happen. And this is a liquid. And the other one is the sodium goes with the phosphate. So Na3PO4, sodium's a +1, phosphate's a -3. To balance, we're going to need 3 in front of the sodium because of the 3 here. That gives me 3 hydrogens and 3 hydroxides. So I'm going to have 3 waters. So you can, again, like with this one, I wrote as H2CO3. Writing as HOH, again, I say about a 50-50 split. It makes it really easy to see how the two, to balance it. And then you can change it to H2O. It doesn't matter to me. States of matter are 2 to start with, are solutions. So they are aqueous and sodium. This back to the question Major had asked me. So on that last page with the chart, the phosphates are insoluble except, so this original thing of the exceptions, the 1A's are aqueous, period. Unless I tell you otherwise, in these double, they are aqueous. All right, so all the ions we split apart. So we'll have 3 hydrogen ions, showing the charge, the +1, a phosphate ion, just 1, PO4 with a -3, and then this 3, the coefficient distributes for its whole compound, so 3 sodiums and 3 hydroxides. Yeah, and we get 3 waters, and our other aqueous splits apart. So this page is really good practice. Your notes are really good practice. Use this weekend of this weather wisely. So do your lab, get the lab done and out of the way. Do it Saturday, do it a day early. And then again, same thing, if you can get it in by 7 on Sunday. If you get in before that, I will look at it. I go to bed pretty early on the weekend. And you can send me emails if you have questions. I'll be there Saturday morning, office hours from 10 till noon. So come, you won't be alone. All right, our spectators are the 3 sodiums. So you can also just underline them and the phosphate. I like to cross them out. Some students like to underline them. But it's not that they're gone. They just didn't react. All right, so again, you'll pull down. So you'll have 3 hydrogen ions, 3 hydroxide ions, and you end up with 3 H2O liquid. All the 3's do cancel. And again, it can be nice in the net to put your aqueuses back on your ions. H2O is not aqueous. Again, aqueous means something is dissolved in the water. H2O itself is pure. We just made more water. We had an aqueous solution. We already had water. We just made more. This is a double displacement acid base. or double displacement neutralization. Either way, I've seen it called both, and I call it both. So whichever way you like. Neutralizing, because the acid and the base neutralize each other. Or you just say acid base. All right, gonna do one more.
Sorry, I have one quick question.
Go ahead.
On number 2 for the gas forming, it doesn't really matter if you write the CO3 before the H2, right? Like it's the same, like they're still in the same reactant.
You have to say the hydrogen before the carbonate. If you write it as H2CO3. Oh, you're saying down here.
Yeah.
In the net, oh, it doesn't matter the order because there's a plus sign between them. I thought you meant in the compound. When you write the compound, so I want to clarify his question because it's a really good question. In the compound, when we write the compound in the first equation, you always write cation before anion. When you write in the net equation, like I wrote the bromide plus the silver. It doesn't matter there because they're separate ions, but in the compound, you have to write the silver before the bromide. So here I wrote it as carbonate plus hydrogen, but you could write it as hydrogen plus two hydrogens plus carbonate. Yeah, I think that's what you're asking me. All right, one more on this page. So solutions of calcium chlorate and sodium nitrate. So calcium plus 2, chlorate minus 1. So we need that 2. And means plus sodium nitrate. So sodium's a plus 1. Now, actually, I want to show you something else. There is another way students will show this where they'll write where my words were. They'll write their charges up there. So because they don't like my charges down here. So they'll say, okay, this is a 1 and a 1, so NaNO3. So if you prefer doing it that way, what I don't want to see is that you're writing like the plus 2 in here and down there, and then I can't tell what's subscripts and what's not. All right. And order some colored pens. The colored's awesome. Right, so calcium's a 2, chlorate's minus 1. They swap partners. So the calcium goes with the nitrate, so CaNO3 2. Again, I think it's for students with the charges right there, it makes it easier. But I'm just trying to show you different ways. And the sodium goes with the chlorate, so NaClO3. So sodium's a 1, chlorate's minus 1. So just one of each. Calcium's a 2, nitrate's minus 1. That's where the 2 came from. Balancing the equation, I needed 2 in front of my sodiums. All right. States of matter. It says solutions. That's my 2 reactants, aqueous and aqueous. So the products. Well, you have that chart, but Nick, you see Nick nitrate, that is aqueous. You see a 1A, that is aqueous. So we're going to go ahead and write the tie out, but what happened here? Does anybody see what's going to happen?
Nothing's going to react.
There's no reaction. This is actually a no reaction. Everything is spectators. Every ion is a spectator. So we'd have all spectators on both sides. Just for completion, we'll write it. So we'd have our calcium ion, our 2 chlorates. We have our 2 sodiums and our 2 nitrates. So I would actually recommend that you go back and do this page again. You can just do it on a piece of paper. Your study set, the first page is just like this. There's 4 or 5 of these to do. And so by the time you get done with your study set, you're going to be very proficient at this. And then on the other side, we get calcium plus 2 nitrates, 2 sodiums. I recommend on the study set that you go through writing it all out like that, because it's good practice. And make sure that you get the idea that this subscript 2 becomes this coefficient, and then this 2 distributes to both the sodium and the nitrate. So again, this 2 became that 2. And then, so there is no net ionic because there was no reaction. Some people also, what they'll do is they'll split apart all their reactant ions, and then they'll say no reaction. I think that's, oh, that part of isn't on there. All right, questions. That's the doubles. So that's the first page of your study set. That's this page, which is good practice. We did that page. So we're doing this page. All right. So pause for like 6 minutes. Pick the equation that you like. Not all of these have net ionics. So only the double are we doing that with. So question 2 is going to have a net ionic. And question 4, my answer is not perfect. We're going to actually do it with another one. But 2 and 4 are the double displacements. I can see that, you would hope, from reading it. But go ahead and try something or take a 5-minute break. I'm going to pause. And Daniela, hopefully you had that. All right, we're on this page 29. So this is where it's all different types of reactions. And we're going to do, so elemental, we're going to put states of matter, sodium and chlorine react. So we're just doing sodium plus chlorine, diatomics. Chlorine is a diatomic. Type of reaction, this is a combo. I know that because it's just a metal plus a non-metal. So I bring them together. I do not bring the subscript over. In the compounds, we put charges. So we have to balance with the coefficients. So we're going to have 2 sodiums, 1 chlorine to 2 sodium chlorides. I highly recommend you put your halos with your sodium and chlorine, because if you put a +1 at the beginning with the sodium, if you do the Leo Gur, you'll get confused. Yeah, let's just keep going so we get practice. Actually, we can go. Let's go ahead and do the Leo Gur. So it is a Leo Gur because we have halos. So sodium is my Leo, chlorine is my Gur, and then my oxidizing agent would be the Cl2. My reducing agent would be the sodium. All right, states of matter. They're elements. Metals are solids. There's one exception to that. Anybody? Chlorine's a gas.
Mercury.
It is. That was Damon again, wasn't it? Yeah, mercury's a liquid. Itself will run into that in an equation, but so there is no water here. Combos, decomps, combustion. Those first 3 types, like on the lab last week, that first page, no aqueous. If they were soggy, if you dumped them in the water, there's no way you can burn it if it's soggy. It's not going to decompose if it's wet. It's going to ionize, but it's not going to decompose. And if you put these in water, you're going to get an explosion if you put sodium in water. So there's no aqueous with combos, decomps, and combustions. So don't make them aqueous. So that means the sodium chloride is a solid. All right, so keep that in mind. So there's no aqueous. It means we're not going to deal with net ionics with these. All right, the next one. solutions of sodium phosphate and barium nitrate. So good old double. They each have a partner. Just did one just like this. So sodium phosphate. Sodium's a 1 and phosphate's a -1. So that 3 pulls down there. Barium nitrate. So barium's a +2, nitrate's a -1. So we do need a 2 there. All right. Gonna take a deep breath. If you didn't do your double displacement, go ahead and try it real quick or keep working on the ones you were. I'm gonna give you people a moment to breathe. Do my meditation for a moment. All right, they swap. Sodium goes with nitrate, just 1 of each, because they each have a charge of 1. So don't switch partners. Barium goes with the phosphate. So we do show the cation before the anion. I like this page without the lines because I can see everything better. All right, so barium phosphate. So balancing, the most complex piece, I'm going to need 3 bariums and 2 phosphates. And that gives me 6 sodiums and 6 nitrates. So 2 times 3, 3 times 2. If you have any trouble on the doubles or any of the equations balancing where you're writing them from scratch, check to see that you got your charges and your subscripts. So that's why I like writing those charges there so you can see where the subscripts come from. States of matter. Aqueous for our first reactants because it told us they were aqueous. Sodium with nitrate, definitely, they're both always aqueous. Barium is an earth metal. This is our precipitate. So just some things, I mean, you can always go back and look at the chart. And so we're going to do our net, our total. I asked for the total and the net. So 6 sodium ions. This 2 and the 3 combined, so you're showing it becomes 6 sodium ions and 2 phosphate ions. You must show the charges. You can leave off the aqueous. Right here, the 3 goes to both of them. So 3 barium ions, so barium +2 or 2 plus. That doesn't matter to me. And this 3 is times the 2, so 6 nitrate ions. Please make sure when you write your polyatomics that it is an oxygen, so not nobelium. Right, arrow. The 6 again distributes out, so we have 6 sodiums, 6 nitrates. So it just takes time. You guys will all get it. The solid, we keep it together. That's what happened here is we made a precipitate. So our spectator ions are the sodium and the nitrate. The spectators are there. They just stay in the solution, meandering around. They just don't have an interest in each other. So our final equation is just the 2 phosphate ions plus the 3 barium ions. And we end up with the barium phosphate. You do show the state of matter for solid, liquid, and gases always. Type of reaction, if you just say double or DD, you will not get credit now. You want to tell me it's a double displacement precipitate. Precipitation, however you want to say it. So it means it formed a solid. Questions? All right, number 3, we're going to take elemental sodium. So that means just sodium as an element, as a solid. It has a halo. It does not like being a halo. it's going to react. You drop it in a bucket of water. So the bucket of water is H2O liquid. And this is a single. A single is an element plus a compound. So this one most students get wrong. So get your erasers out because they want to put the sodium with the oxygen. So remember how I kept saying, oh, you can write water as HOH, and I commented, that's because that's really what it is. When water reacts, it breaks into hydrogens and hydroxides. We talked about that when we did the pH question. So the sodium is going to combine with the hydroxide. So it doesn't pull apart as hydrogen and oxygen, it's hydrogen with a hydroxide. So you get sodium hydroxide and hydrogen. All right, what's wrong with my answer? Sodium has a +1, hydroxide is a -1.
Hydrogen's a diatomic.
Yeah, diatomic. Hydrogen's a diatomic by itself. So H2 and hydrogen, what's in the sun, it is a gas. So I have a compound here. Is it aqueous? Yeah, we have a liquid. We have, I'm not a liquid, we have water. We have a whole bucket of water. This you get a bang, so that's aqueous. And we do need to balance our equation. So these two hydrogens, yeah, if it's not working, you always go back and put a 2, but we end up with 2's everywhere because of that 2 subscript with the hydrogen. So it's 2, 2, 2, and H2. It is a single. Now, we can do, we'll move on. We'll do it with number 5 because I have more room. Let's go ahead and do Leoger. Reminder, diatomics do get halos because they are by themselves. So the sodium's going from a 0 to +1. That +1 means it lost electrons. So sodium is my Leo. That means my reducing agent is the sodium solid. My Ger, hydrogen is a +1 and it ends up at a 0. So the hydrogen's my Ger. My oxidizing agent, kind of weird, but it is going to be the H2O. The oxygen doesn't change. The oxygen's a -2 on both sides. But if you have a halo, you do Leoger. Questions with that? All right. Solutions of potassium hydroxide and sulfuric acid. So potassium hydroxide is KOH. Sulfuric acid is H2SO4. And so sulfate's a -2. That's why we have 2 hydrogens. And potassium's a 1 also, hydroxide's a -1. So we have KOH and H2SO4. If you want, you can put your states right away. They're aqueous. You can write your states in a different color if that helps you. And it is a double, but we're going to have to put another word. You might see what it is right off. What type of double is it? It's a double acid base because hydroxide and hydrogen. Sometimes that's nice to recognize right off because it means we're going to make water. That's what happens in the acid base. They neutralize to form water. Water's neutral. Potassium goes with the sulfate, so K2SO4. Sulfate's a -2, K is a +1, so that's where my subscript came from. So again, they don't have the same charge. We need a subscript. So hopefully, you know, a month ago we learned naming and it was like, oh my gosh, what is she doing? Hopefully you're becoming more proficient with at least the ions and stuff. And then the hydrogen and the hydroxide go together to form water. Again, you can write it as HOH, or you can write it as H2O. We don't see many liquids. In fact, for this celebration, the second midterm, I'm pretty sure the only liquid we're going to run into that you're going to be writing equations is water. Potassium, the first column, these guys are aqueous. All right, we do want to make sure we balance. If you forgot to balance, your net ionic, I'm sorry, and your spectators won't cancel out. And so then you just have to go back and remember to balance. We need 2's in front of the K's. I'm sorry, 2 in front of KOH and 2 in front of H2O. All right, so it's a double displacement acid base. All right. Now, some students can write off, see that the thing that is aqueous on both sides is going to be the potassium and the sulfate. So sometimes, I'm going to go back and write my middle step, but sometimes you can see right off that you're going to end up with the H2O liquid. On the study set, I ask for you to write all 3 steps, but there are times when it says it's up to you if you want to write it, that we're going to end up with the liquid, and then on this side must be the ions that made it, which is the 2 hydroxides. And the hydrogen has to be written as 2 hydrogen ions. So it is not H2 gas. This is aqueous. It's ions. You can put the aqueous. It might help you. You do have to cross the 2's off. The 2's, you can cross them off, you can erase them. Again, I see about a 50-50. I have no problem crossing them off, and I didn't realize that half of you do, and you're not alone if you do. Apparently it's more than half of you, so you have to have it nice and neat, and so you have that eraser that you erase the pieces. But that would be our net ionic. The spectators are potassium sulfate. I'll go through and write our middle one just for completion. 2 potassiums, 2 hydroxides, 2 hydrogens, and sulfate. I would say 90% of you, you're going to want to always be writing that total. There's always a few students, maybe like 2 or 3 of you, who can see right off. And it just has to do with how our brain sees stuff. For most students, writing out the ions, and on the studies that I ask you to, because that's part of the learning process, is as you keep writing them out, you start seeing it visually different. And then this aqueous, the 2 potassiums and the sulfate. And we get to H2O. Again, you can write it as HOH, and at this point go to H2O. That's, again, a personal thing. All right, we got one more. Then we got a whole nother page of practice that we can decide. Magnesium metal. So we have magnesium. And it's a metal, so it's a solid. It has a halo. Put that halo there. It's not an ion because it's a metal. If it was an ion, it would have been either in a compound or said ion. And it's added to hydrochloric acid. That prefix hydro means it's just HCl. And if you see that word acid, it means it is aqueous. So hydrochloric acid, hydrogen is +1, chloride's -1. This is a single. So a single, right? They just switch. They switch part. I'm sorry. They you have a element plus a compound. We do an arrow, and all right. So go ahead, do your switch, balance it. the magnesium goes with the chlorine. So hydrogen, right? We don't want to put two things that are on the same side of the periodic table. So hydrogen is a non-metal, but it does not combine with metals in nature. So in this chemical reaction, that's not going to happen. That magnesium is a +2, so we need a subscript 2. And hydrogen ends up by itself, so it gets the halo, and it's a diatomic. It is a gas. All right, let's do 2 more things. We have to do a couple things actually with this one. We do need to balance. We have 2 hydrogens and 2 chlorines, so we do need the 2 here. And then we have to figure out the state of matter of magnesium chloride. So the chart, chlorines are soluble, except with silver, mercury, and lead. So magnesium chloride is soluble. It is aqueous. Since I have something else that's aqueous, it's still aqueous.
Wait, I thought it was like Mg magnesium is an exception. I thought it says that there. And like the fluorides.
This is chloride.
Oh, okay.
So yeah, you were right. That was the fluorides, but the chlorides is just silver, mercury, and lead. Yeah, so again, for next Thursday, make sure you have your stuff organized. So your periodic table, your polyatomics, so you happen to refer to this chart. Yeah. All right, we have 2 things to do with this one. Any other questions with it? We're going to do the tie and nye with this. Why can I do a tie and nye with this one? I have aqueous on both sides. If you have aqueous on both sides, again, it will not happen with a combo decomp and combustion. They have no aqueous at all. Doubles, absolutely. And singles will do the tie and nye. So on your study set for Tuesday, the first page is the doubles, and then the second page is doing tie and nye with the singles. And then your worksheet is kind of like this page, or this page where it's just all mixed up and you do Leo Gur and stuff. So let's go ahead and do the tie nye because it's slightly different with the singles. So this is a solid. It stays as a solid. Only the aqueous do we change and break them up. I recommend that you keep that halo there. Right? If you don't put that halo there, you're going to have a problem later on. All right, this is aqueous. This we split up. So 2 hydrogen ion plus 2 chloride ion. And we'll put our arrow. All right, on the product side, aqueous, I split up, and ions gets charges. The 2 does move up because it's an ion. So magnesium +2 and 2 chlorides. Now, I said earlier, you can leave the aqueous off in the tie. Unless you have trouble with what I'm going to do next. The hydrogen, I keep it as H2 because it's a gas. So the chlorine, the 2 moved up because it's aqueous. So it's only the aqueous that's going to change in the tie step. Questions? All right, so the trick, I don't really like that, but the trick or the treat is these were called doubles, and they always had 2 spectators, sodium, nitrate. On this one, it was the potassium and the sulfate. This is a single, there's one spectator. There's only one thing that crosses out. They may see what it is, or you all see what it is, maybe. And that is the chloride. Yeah. The chloride is the only thing that is an ion on both sides. And actually, I wanted to make a quick comment. So somebody said chlorine, and that's fine, but just a small correction. When we say chlorine, we're actually talking about Cl2 as a gas. When we're talking about ions, we say ide. And that actually makes all the difference because chloride is actually safe because it's already reacted. When they use chlorine, that's caution because it's got the halo and it's going to react. Anyway, you can ponder those things. So only the chloride cancels. Why does the magnesium not cancel? Because I see a magnesium here and then I see a magnesium there.
One's solid, one's aqueous.
One is solid and one is aqueous. Yeah, and so that's why if it helps you to write aqueous, so a solid and an aqueous don't cancel out. So if we're going to, on the next step, definitely show it. And the other thing is the one had a halo and the other one does not. Those halos are so awesome. So we have a 0 and we have a +2. That's not the same thing. This is an ion. This is a solid. So one is aqueous and one was not. And then the same with the hydrogen. So the hydrogen on the one side, it is two hydrogen ions. And so we want to show it with its charge and the aqueous. So it could be very helpful to write your aqueous in the total, especially when I give a little bit more room. I didn't give much room on some of the other ones. So it's like a mental note to myself. You can always do it on a piece of notebook paper instead of on the page, or you just write smaller than I am. All right, it is balanced, the two hydrogens. That is our net. We have one more step, the questions before our last step. All right, what's our last step? Leo? So you're the red ox, so it is always such a relief when the new moon comes. It's also a new moon in Aquarius, so several people, like Julia has a birthday on Monday. We should all sing to her. It's really fun singing to somebody on Zoom because everybody's Wi-Fi is different, and so it's like the worst singing version of happy birthday. So I'm going to show you something with Leo Gurr. You can always do it back with the original one. The magnesium went from a 0 to a +2. So magnesium is my Leo. It's oxidized. Its oxidation number increased as we read across. The +2 means it lost electrons. You can also do it with your Net Ionic if you got your Net Ionic correct. So if you're comfortable with the Net Ionic, it's actually easier with the Net Ionic. So my Gurr is the hydrogen because it's a +1 goes to a 0. The spectator is never your Leo Gurr because it's a spectator. It was just an ion on both sides. And so on the net, if you're really good with the net, it's actually easier to see the Leo Gurr. So we're going to finish our chart. Let's do our oxidizing agent and our reducing agent. So the magnesium's Leo, so magnesium as a solid has to be as the reactant. The magnesium is my reducing agent. I wanted to remind you, I keep for some reason asking for the oxidizing agent, but sometimes I do ask for the reducing agent. So whatever was oxidized is called the reducing agent. So the oxidizing agent, there's two answers that are accepted. They're actually the same answer. And so you could either say for the oxidizing agent, the HCl, but it's actually the hydrogen ion that did it. So either HCl or hydrogen ion, not hydrogen, because the hydrogen gas is over there. So HCl or H plus. Don't give me both, just give me one or the other. So questions. So I do realize we have one more page. And on Tuesday, we're going to do this page as part of our practice, because it's actually really good practice. So if you want, you can do it before Tuesday, or Tuesday we'll go over this page. Yeah, I will post it on the review, but it may say, hey, go back to page 30, or I can put it in there. But is there any questions? I'm going to stop us unless there is a question.